we are here to discuss the investigation on voltage collapse incident in Sri Lanka. Today here we have me, Brendan, and Pratisha. Okay, let's start the discussion. Okay, let's start with the introduction. The investigation of a voltage collapse incident in Sri Lanka power system network is a critical endeavor aimed to understanding the causes and the consequences of a significant disruption in the electrical supply. This incident has a profound impact on the power grid, resulting in widespread of power outage and disruption. By truly analyzing the event and its contributing factor, the investigation seeks to enhance the stability and reliability of the power system, ensuring uninterrupted electricity supply for the country's economic growth and the well-being of its citizens. Moving on, this is the incidents on the 2nd May of 1995. The Sri Lanka power system network has an installed capacity of 1,385 megawatt, primarily relying on hydropower. However, the network is comparatively weak. The bulk power generated at the Mahaweli complex is transmitted through 220 kilowatt double circuit line to Colombo, supplying over 50% of the country's peak demand. This heavy reliance on power transfer through this line is evident from the occurrence of major failures in the past 5 years. Out of 7 incidents, 3 were attributed to the tripping of Kotmel Biyagama 220 kilowatt lines.
Okay, as for the main event of the incidents, on 2nd May 1995, major blackout accident was happened. The system was operating in the steady state before the incidents took place and supplying a peak demand of 981 megawatt. The 220 kV lines between Kotmel Biyagama were transporting about 500 megawatt power to Colombo area. Okay, this is the chronology that happens. 3 different reports are available on the incident of major blackout on May 2nd, 1995. From the reports following can be observed. The system was operating in the steady state before the incidents took place and supplying a peak demand of 981 megawatt. The 220 kV lines between Kotmel Biyagama were transporting about 500 megawatt power to Colombo area. So second, at about 6:45 p.m., a lightning strike took place about 26 kilometers from Biyagama, causing one of the lines to trip due to distance relay protections. Third, the second line also tripped with distance relay operations in less than a second. Fourth, the tripping of the above 2 lines caused a deficit of about 500 megawatt power in Colombo area, leading to cascade tripping of loads and resulting into total blackout at about 6:58 p.m. The restoration efforts could bring the system back by 8:33 p.m. Total loss estimate was 851.9 megawatt per hour. Okay, this is the data for intake case. As we can see here, there are between voltage and load factor. So here is the ranking of weak buses at the initial loading. The difference between this we can see from the weak buses or copious point for the intake case is the tangent vector. So for both, the difference is only tangent vector. Next. As for data for one line out edge case, this is the voltage profile at few critical buses and two non-critical buses, one line out edge case. And for this also the same, there's a ranking of weak buses with one line out edge for the normal load and cold-paste points. So the difference is for both table is the tangent vector.
Protection system. At about 6:45 p.m., a lightning strike took place about 26 kilometers from Viagama, causing one of the line to trip due to distant relay protection. The second line also tripped with distant relay operation in less than a second. Next, the main cause of the incident. Firstly, in Sri Lanka, power system network no static voltage instability. The second, the system had enough static voltage stability margin in these two conditions. Number third, the system lead to infeasible operating condition with the outage of both the lines. Number fourth, outage of the first line was due to the lightning, whereas the outage of the second line was due to picking of distant relay, not because of any fault, but due to reduced voltage to current ratio impedance during dynamic voltage collapse. And for the impact of the incident, the tripping of the above two lines caused a deficit of about 500 megawatt power in Colombo, area leading to cascade, tripping of loads and resulting into total blackout. Affect the society. The restoration effort could bring the system back take more than 1 hours, 6:58 p.m. to 8:33 p.m. And the total loss estimate was 851.9 megawatt per hour.
Okay, the lesson from this from the incident is uh, for me, it is to reduce the restoration time so that it can reduce power loss in megawatt hour.
Okay, as for me, we can prevent the overload by set the limit of the load in each system. So consider the cascade tripping.
For mine is to prevent the reduce the voltage to current ratio impedance during dynamic voltage collapse because it will trigger the distant protection relay.
Okay, from this discussion, we can conclude that this incident happened because of the failure that happened in the power system that causes the major blackout. This incident give impact to the society and engineering such as power losses and blackout. So from this incident in Sri Lanka, we should understand and find the causes of the problem to prevent this incident to happen again. That's all from us. Thank you.